This next chapter 5 is quite short on ratios and proportions. So what is a ratio? All right, I mean, it's another way to think about fractions that we looked at in chapter 3. So a fraction a over b, it means a divided by b. And we're really comparing these two numbers, comparing the a and the b. So that's all a ratio is. So the ratio of a to b, written like this with a colon, it just means the fraction a over b. All right, so it's just another way to think about comparing the sizes of two numbers. For these ratios, the a and b are usually positive integers. And we usually want to use numbers that are as small as possible, so it's the same, really the same as simplifying fractions. We want to reduce the fractions to lowest terms, so cancel any common factors. All right, so let's see. Example 1. Suppose a team wins 15 games and loses 5 games. Give the ratio of wins to losses. In this example, we're just comparing these two numbers, the 15 with the 5. So the main thing to remember, for the ratio of a to b, the number a goes on top, the number b, the second number, goes on the bottom. So we have 15 over 5 in this example, and we can simplify that fraction. There's certainly a common factor of 5. So 15 divided by 5 is 3. 5 divided by 5 is 1. We want to keep it as a fraction. It's just the whole number 3, but as a fraction, it's 3 over 1. All right, so the simplified ratio is 3 to 1, and that's the answer. So the ratio of wins to losses for this team is 3 to 1, or you can write it with a colon, 3 colon 1. All right, and you can see why this is useful. So it's helping us understand how well this team is doing. So we can see here it's winning 3 times as often as it's losing. So it's we have this ratio of wins to losses, 3 to 1. All right, example 2 for the same team. Find some different ratios. So A, the ratio of losses to wins. B, the ratio of wins to total games played. Okay, losses to wins. So the team has lost 5 games and won 15. So losses to wins is 5 to 15, just switching the order. And then if you simplify 5 over 15, that's 1 over 3. All right, right, so we're just switching the two numbers here. So the ratio of losses to wins is 1:3, or 1:3. How about part B? So wins to total games played. Well, 15 wins. What's the total number of games played? Well, that'll be 20, right? So including all the games, 15 plus 5 is 20. So 15 wins, and we're comparing that this time with the total number of games played. So it's the ratio of 15 to 20. And again, simplify that. 15 over 20 is a common factor of 5. Divide by 5, so we get 3 over 4. Okay, so the answer to part B, the ratio of wins to total games played is 3:4. Okay, and yeah, so we can see out of every 4 games the team played, it won 3 of them. All right, so that's a good example of, these ratios. We're just comparing two quantities. We want to make it as simple as possible. So simplify the ratios just means reduce the fractions to lowest terms. Example 3, write 25% as a ratio. So what is 25%? Well, if you remember, 25% as a fraction, it's 25 over 100. All right, so this is the fraction, and we can simplify it. Cancel 25s, that's 1 over 4. So as a simplified fraction, 25% is 1 over 4. And as a ratio, that's 1:4, or 1:4. All right, so yeah, nothing really new here. We're just looking at fractions in a slightly different way. Example 4, maybe you've got a big new TV, so maybe your giant new HD TV screen is 34 inches wide and 64 inches wide and 36 inches high. I'll find the ratio of the width to the height. So this is called the aspect ratio for the TV screen. So we're comparing the width here, 64 inches, to the height, 36 inches. Okay, so we can make this fraction. So it's, I guess it's really 64 inches over 36 inches. But when you make a ratio of measurements like this, the units cancel. So you just get a pure number. And we can simplify this fraction. This common factor is 4. So if you cancel out the 4's, that's 16 over 9. So the ratio we're looking for, width to height, is 16 to 9. All right, and that's the usual aspect ratio for new TVs. All right, in the book, yeah, ratio a to b is just the fraction a over b. And yeah, we want to reduce it to lowest terms. This example, the ratio of 9 to 18. We'll make the fraction 9 over 18 and simplify it. So we get the ratio of 1 to 2, 1 colon 2. The ratio of 21 to 12, 21 twelfths. Yeah, I think we can cancel 3's. So we get 7 to 4. And 64 to 4 is 16 over 1. Yeah, it's just the whole number 16, but we want to keep it as a fraction, so 16 over 1. So for a ratio, you need two numbers. So 64 to 4 simplifies to 16 to 1. All right, here's a more complicated one. What is the ratio of 3 3/4 to 1 1/2? Okay, so we're comparing two numbers. This time we're comparing two mixed numbers. And don't forget, yeah, the operation is division, so we have A divided by B. So how do you divide mixed numbers? Well, you have to convert them to improper fractions. So 3 times 4 plus 3 is 15. So the first guy is 15 over 4. 1 times 2 plus 1 is 3. The second guy is 3 over 2. Keep change flip. So to divide by 3 over 2, that's the same as multiplying by 2 over 3. All right, and you get 30 over 12. Cancel 6's, that's 5 over 2. Or better here to pre-cancel, cancel 2's, cancel 3's. All right, so dividing these two mixed numbers, we end up with a fraction of 5 over 2. And that's what we're looking for the ratio. So the ratio is 5 to 2. All right, so yeah, if you're trying to find the ratio of any two numbers, maybe two fractions, two mixed numbers, two decimals, just do a division and write the answer as a fraction. And that gives you the ratio. All right, and again here, yeah, so to divide two mixed numbers, convert them to improper fractions. Dividing by fractions the same as multiplying by the reciprocal, so flip over that second guy. Then multiply straight across. Okay, how about this one? What is the ratio of 22.5 to 15? All right, yes, so we want to divide 22.5 by 15. Yeah, maybe an easy way to do that is to, so yeah, we saw this trick when we were dividing decimals, moving the decimal point. Yeah, if you multiply top and bottom by 10 here, you can make the top a whole number. So we get a fraction of, so just a regular fraction, and then yeah, simplify it. I guess there's a common factor 75. You can cancel, so 3 over 2. Okay, and yeah, you get the same thing. So if you just did this division So 15 into 22.5. You'll get the same answer. So 15 goes into, we're divided by a whole number, so line up the decimal points. 15 goes into 22 one time. Subtract, we get 7, and bring down the 5. 15 into 75 goes 5 times. Okay, so yeah, we get 1.5. Yeah, that's the same as 3 over 2. But when we're dealing with ratios, yeah, it's more useful to have a fraction. Yeah, if you convert 1.5 to a fraction, yeah, it's 1 and 5 over 10. That's 1 and 1/2. As a fraction, that's 3 over 2. Okay, so we get this ratio 3 to 2. Okay, so comparing these two numbers, 22.5 and 15. So if you compare the two sizes, it's the same as 3 to 2. Right here we're comparing quantities with different units. So this is like the mixed units we looked at before. Here we're comparing $15 to 30 cents. All right, so $15, that's going to be much bigger than 30 cents. So how do we compare these two? Well, it's a good idea to write them both in the same units. So $1 is 100 cents, and we have $15, so that's 1,500 cents. All right, so yeah, we need the same units to be able to compare these properly. So it's really 1,500 over 30, and you can there's a common factor 30. So divide top and bottom by 30, you get 50 over 1. All right, so the ratio we're looking for is 50 to 1. All right, so that's really telling us that $15 is 50 times bigger than 30 cents. All right, yeah, so just remember, if you're comparing, say, dollars to cents or hours to minutes, just convert everything into the smaller unit. Then you can compare them properly. And again, yeah, here the cents sort of cancel. You just get a pure number. Yeah, here's one comparing minutes with hours, right? The same idea. Manuel gets a 5-minute break for every hour he works. What is the ratio of work time to break time? All right, so looking, so for every hour, 5 minutes of that is a break. 55 minutes is actual working. So work time to break time is 55 to 5. or 11 to 1. Yeah, here we're just using that there are 60 minutes in an hour, so 60 minus the 5 break is 55. All right, so yeah, one more. At a certain community college, 55% of the students are female. Find A, the ratio of female students to the total number of students, and B, the ratio of females to males. All right, so 55% means the fraction 55 over 100. Okay, so 55% of the students are female, so out of every 100 students, 55 are female. And we can reduce that, cancel 5s, so we get 11 to 20. So yeah, we can write the ratio of female students to total students is 11 to 20. And that's part A. How about part B? So, well, if 55% are female, then 45% have to be male. So the total is 100%. So comparing females to males, now we're comparing 55 to 45. And that fraction reduces to 11 over 9. Cancel 5s. All right, so for part B, the ratio of female students to male students, that's 11 to 9. So as you expect, you have slightly more females to males. All right, so next section is on proportions. So to introduce those, here we saw a few minutes ago we had this calculation. So 15 over 20 is equal to 3 over 4. Yeah, just cancel 5s here. So we have these two equivalent fractions. Yeah, if you simplify 15 over 20 to lowest terms, that's 3 over 4. In terms of our ratios, you can say that the ratio 15 to 20 is really the same as the ratio 3 to 4. All right, so something like this, saying that two ratios are equal, that's what we're calling a proportion. The definition, a proportion states that two ratios are equal, and it just looks like something like A over B equals C over D. So you're saying that two fractions are really represent the same number. So if you do have two equal fractions, two equivalent fractions, then that gives you a true proportion. Okay, you can write down proportions that are not true. If the two fractions are not equal, then it will be false. So that's a basic question. If I give you a couple of fractions, is the proportion true? Are the two fractions equal, or are they false, not equal? So part A here in this example, we're comparing 6 over 14 with 9 over 21. So are these equal? Is this a true proportion? Well, one way to check here is to, if we simplify both fractions, do we get the same thing? Well, 16 over 14 does a common factor 2 we can cancel, so that simplifies to 3 over 7. And yeah, you can see 19 over 21 canceling 3's, that simplifies to the same fraction. So this is true. So this first one is a true proportion. How about the second one? Is 5 over 10 equal to 3 over 5? Yeah, this one looks a bit more suspicious. Yeah, if you simplify these, so we're getting 1/2 equal to 3/5. Yeah, I don't think so. Maybe the best way to compare them is to write them over a common denominator. So write them both over 10. So 3/5 is the same as 6/10. So yeah, now we can definitely see that 5/10 is, yeah, it's not equal to 6/10. All right, so this second one in part B, this is false. Right. That one was good, but this one's not true. All right, in fact, there is an easier way to check if a proportion is true or false using cross products. Okay, so let's look at these same two guys again. 6/14 and 9/21. All right, so for the cross products, you're multiplying 6 times 21. So that's the first cross product. And then 14 times 9, that's the second cross product. 6 times 21, that's 126. 14 times 9, that's also 126. So if you work out the two cross products and get the same number, then that tells you the proportion is true. But if the cross products are different, so here we're getting 25 and 30, so those two cross products are different, that tells you that the proportion is false, so they're not equal. All right, so yeah, this is the time that you do cross multiplying when you're checking proportions. All right, so let's use this to look at another example. Example 6. Use the cross product property to see if 9 over 20 is equal to 4 over 9. Okay, so do we have a true proportion here? Well, let's work out the cross products. So the first cross product, that's 9 times 9, 81. And the other cross product is 20 times 4, and that's only 80. Yeah, so they're close, but not equal. So this proportion, this equation, is false. Yeah, the proportion is false, the equation is false. 9 over 20 is not equal to 4 over 9. Yeah, you could also check, use common denominator 180. All right, so okay, yeah, in the book, a proportion is a statement like this: A over B equals C over D. And here's that cross product property. So A over B is equal to C over D if and only if AD, the first cross product, is equal to BC, the second cross product. And yeah, so why is that true? So why do we have this if and only if? Well, yeah, if two things are equal, then if you multiply both sides by the same number, it's gonna stay equal. Same thing if you have two things that are equal and you divide both sides by the same number, it stays equal. So starting with A over B equals C over D, the trick is multiply both sides by BD. So if this is equal and you multiply by the same thing, then this is also going to be equal. But now here we're multiplying by B and we're dividing by B. So those B's cancel. We're left with dA. Over here, the D's cancel. We're left with BC. Yeah, dA is the same as AD. All right, so if this is true, then multiplying both sides by BD, we get this. So this being true implies AD equals BC has to be true. And you can go backwards, divide both sides of this by BD, you'll get the first equation. And yeah, so going from here to here, it's this idea of clearing fractions. Okay, but yeah, we're starting to look at equations now. So equations are just saying that the left side's equal to the right side with the equality symbol. And then the rules for dealing with equations, yeah, you're allowed to multiply both sides by the same number. So starting with something true, you'll keep something true, or divide both sides by the same number, you'll get another true equation. All right, so that's why it works. So just remember to check a proportion's true, work out the cross products, and check that they're equal. And so another example, how about 3 over 11 equal to 2 over 7? So is that a true proportion? Well, the cross products are 21 and 22. So no, that's false. How about 4 over 10 equal to 6 over 15? Yeah, the cross products are both 60, so this one's true. All right, so it's kind of nice, yeah. So we're working with fractions, but we can convert it to a question with no fractions, just multiplying two numbers and checking if they're equal. And yeah, just another point I wanted to make here. Yeah, this cross multiplying, this finding cross products, it's only used for checking proportions. Remember, when we're multiplying fractions, that goes straight across. All right, so yeah, I know a lot of you like to cross multiply when you're multiplying, but no, it should go straight across. So 3/4 times 5/7, the correct answer is 15/28. So we're straight multiplying. Okay, what's this? Solving proportions. Okay, we saw this true proportion earlier. 15/20 equals 3/4. But if one of these numbers was missing, say the 3 was missing, let's replace it with a question mark. So if that 3 was missing, could we have, so starting with this question, can we find the missing number? All right, so yeah, if I give you a proportion with one of the numbers missing and ask you to find the missing number, that's called solving the proportion. And yeah, instead of a question mark, yeah, we usually write an X, or yeah, any letter to represent the unknown number. All right, so example 7, yeah, the same question. Solve the proportion 15/20 equals x/4. And here solve means you have to find what x has to be to get a true equation, to get a true proportion. So what number does x have to be to make this true? So how do you solve proportions? Well, we know for this proportion to be true, the cross products have to be equal. And yeah, it's really if and only if. So if we can make the cross products equal, then we'll have a true proportion. So what are the cross products here? So we have 15 times 4 and 20 times x. So we want these two to be equal. 15 times 4 is 60. So we want this to be true. We want 60 to equal 20 times x. Well, what number should you multiply 20 by to get 60? 3. 20 times 3 is 60. All right, so yeah, we knew we were looking for 3, but this is a way to find it. So x equals 3. And we say 3 is the solution. 3 is the number to make this work. Yeah, another way to do this question, maybe easier. Yeah, this 15/20, we could have simplified that. It's, in lowest terms, it's 3/4. So simplifying 15/20, we get 3/4, and we want that to equal x/4. So yeah, now it's clear. So what does x have to be? Yeah, x has to be 3. So that's another way to do this question. Any way you look at it, yeah, we need a 3 here. Okay, how about this one? Example 8. Solve the proportion 6 over 12 equals 10 over x. Okay, so again, we're looking for what number should that x be? What should we replace that x by to get a true proportion, to get a true equality here? Well, yes, 6 over 12, that certainly simplifies to something simple. That's just 1/2. So we get a simpler proportion we're trying to solve. Set the cross products equal. So this is 1 times x, and this is 2 times 10. Okay, so 1 times x, well, 1 times anything is just that same thing, x. If x was 17, 1 times 17 is 17, so multiplying x by 1, we just get x. 2 times 10 is 20. And we want the cross products to be equal, so we want x to equal 20. Yeah, so put a 20 on the bottom, then it works. 10 over 20, that's also 1/2. So the answer, the solution is x equals 20. Okay, how about this one? Instead of an x, we have a capital B. 33 over this mystery number is equal to 3 over 5. Yeah, this time the 3 over 5, we can't simplify it. It's already in lowest terms. So we'll set the cross products equal. So we want 33 times 5 to equal b times 3. 33 times 5, that's 165. B times 3, yeah, that's just switch the order. We usually write it like this: 3 times the letter, 3b. All right, so we get this equation. So now we're trying to solve this. So what should be? So what number should we put in for b to get a true statement? So what number times 3 equals 165? Okay, yeah, now we're trying to solve this equation. We're going to look at equations more in chapter 6. But for something like this, it's easy. The idea is, yeah, we have 3b on the right. We're looking for 1b. We're looking for just b. So 3 times b is 165. So if we want 1 times b, we're going to divide both sides by 3. Divide this by 3. Divide this by 3. So as long as you're doing the same thing to both sides of an equation, so if it starts off true, then it stays true. And 165 divided by 3, yeah, you can check it's 55. All right, so this makes sense. So the number we need for b is 55. 3 times 55 is 165. But whenever you have a situation like this, a number equal to a number times your variable, your letter, and just whatever number is multiplying the letter, divide both sides by that same number to get just the letter, just the variable. All right, so the answer here, B, is 55. Yeah, maybe you could have seen that in other ways. So yeah, if B is 55, then this definitely works. 33 over 55, if you cancel 11s, you get 3 over 5. So yeah, final step, you could substitute the number and check it works. Okay, a few more examples. All right, so here's a proportion we're trying to solve. X over 3 is equal to 34 over 51. .34 over 51. Yeah, I think that does simplify, but let's just do it. Follow the book here. So that the cross products, here we have x times 51, or 51x. The other cross product is 3 times 34. Yeah, that's 102. Okay, we've got rid of the fractions at least, but we still have these big numbers. 51 times x is 102. We're looking for 1 times x, so divide both sides by that 51. Okay, so x is 102 over 51, that's just 2. All right, so yeah, I guess a better first step would be to, yeah, if you see there are 17s here, so cancel the 17s. And this is just the same as x over 3 equals 2 over 3. Okay, how about this one? Some more big numbers. We have 9 over 100 is equal to 36 over y this time, letter y. Solve the proportions, so find what the y has to be. Okay, yeah, this doesn't simplify. So set the cross products equal. 9 times y is equal to 100 times 36. So 9y, the first cross product, is equal to 3600, the second cross product. We're looking for 1y, so divide both sides by 9. So if this is true, then dividing by 9, this is true. And yeah, if you do the division, yeah, 9 goes into 3600 400 times. So the y we're looking for is 400. Yeah, and you can, once you've got the answer, yeah, you can see that it does make sense. So if this is 400, you can see, yeah, if you multiply the top by 4 and the bottom by 4, 4 times 9 is 36. 4 times 100 is 400. So yeah, so these are certainly equivalent fractions. Okay, how about one last one? Solve this proportion. 10 over b equals 15 over 4. 15 over 4, that doesn't simplify, so set the cross products equal. 10 times 4 is 40. b times 15, well, we write that with the number first, so 15b. Okay, 15b equals 40, so divide both sides by 15 this time. Okay, so b is equal to 40 over 15. Cancel 5s, so this 40 over 15 simplifies to 8 over 3. So yeah, so this time the answer b is not a whole number, it's a fraction. Yeah, you could write it as a mixed number, 2 and 2/3. But yeah, there'll be some questions where the number you're looking for is not a whole number, so yeah, it could be a fraction, a mixed number, or decimal. All right, so that's starting our this chapter 5, ratios and proportions. And we'll see applications in the next section.